All right, everybody, this is lesson 1.6, two-dimensional figures. Again, I have rewritten many of these notes, and if you would just pause this, copy down what I have, similar things, that's what we'll be looking at and grading you on. But we're going to talk about two-dimensional figures today. Very easy stuff that you've probably done in the past. This right here is a polygon. And a polygon is a closed figure formed by finite number of coplanar segments called sides such that first thing is those sides have a common endpoint. Sides have a common endpoint, and they're non-collinear. And then each side intersects exactly two other sides. But only at their endpoints. Okay. That's a very long definition, but there's a reason for it, okay? Because we have to talk about what makes a polygon and what makes a polygon not a polygon. And these really are the two most important parts, that the sides have a common endpoint, they're non-collinear, and that each side intersects exactly two other sides, but only at their endpoints. So right here I have this, we would actually call it polygon, whoops, GHJKLM. And to be honest, you could start at K if you had liked and called it, I like to call it polygon KLMGH. It's fine. Just make sure you go all the way around. This right here is the side, and it's a line segment. And you name each side just like that. You would have, side GM with a line segment over it, and side GH, etc., HJ, on and on and on. And then each one of these points is called a vertex. Every multiple points are called vertices, but one point is called a vertex. Now, let's talk about why there was such a long definition, okay? Because polygons, you're probably all familiar with like triangle is a polygon, and, a long rectangle is a polygon, and trapezoids, which is still a four-sided figure, and then obviously this right here, that polygon. I had a teacher friend who used to call that a machine gun. Hysterical. No one's laughing. Anyway, these are not polygons. You can't do that. You can't have like a figure that looks like this with curved sides. Okay, or even like, oh, that's an oval. Yes, it is an oval, but it's not a polygon by definition. Okay, so just some examples. Now, you should know these names, I hope. You need to know what a 3, 4, all the way up to 12-sided figure is called. There are names, you can Google it if you want, for what comes after 12, like a 13-sided figure and a 14-sided figure, etc. But just make a list real quick. Again, if I'm going too fast for you, pause the video. A 3-sided figure is called a triangle, and a 4-sided figure is a quadrilateral. A 5-sided figure is a pentagon. And a 6-sided figure is a hexagon. 7 is where everybody gets confused. They always want to call it a septagon, but it's actually a heptagon. Hexa is 6. It has the like SIX spells 6, so hex. Hepta is with 7. 8, good old stop sign, octagon. 9, nonagon. And 10 is decagon. And then after 10, 11 is called hendecagon. Hen being a prefix for 1. 1 and 10 make 11. 12 is actually called dodecagon because do is the prefix for 2. So 2 and 10 make 12. Anything after 12, honestly, you can call it a n-gon. So like a 13-sided figure would just be a 13-gon. That's all you'd have to call it. All right? So that's our intro to polygons. Now, let's talk about what makes a polygon regular versus irregular. Okay, and it really just depends on those red marks. Those marks are so important that they put around a polygon. A polygon is regular if it has all the angles congruent and all the sides congruent. Now, I'll be honest with you. I did not draw a very good regular polygon, but that's not the point. The point is that you look at the marks. These marks are important. If all the sides are congruent and all the angles are congruent, then you have a regular polygon. All sides and angles are congruent. An irregular polygon would then be the opposite. So you could still have two sides congruent, but then these two sides are different measures. And that's what, well, actually have 4 sides that are congruent. Even so, they all have to be congruent to be considered irregular. So this is an irregular polygon. All the angles are not congruent. All the sides are not congruent. Convex polygon versus a concave polygon. And the way I remember this is if it caves in, it's a concave polygon. It's got to have a caving point, right? Somehow. They give you another definition in the book about like line segments going through the interior, and I think that just, if you can see, look how it's caving in. This one's caving in, then you're going to call it a concave, whereas these are all convex. Okay, they're not concaving in. All right, and then the last 3 things we're going to talk about are perimeter, circumference, and area. 3 favorite things in geometry. So perimeter, which you should all be familiar with, is for a polygon. It's just the sum of all the lengths of the sides. Sum of all the lengths of the sides of a polygon. And circumference now would be the perimeter of particularly a circle. Remember, circle is not a polygon, but it's still included in this chapter because it's just a special shape that we still want to know. Okay, so it's the distance around a circle. The area would be the number of square units needed to cover the surface. And the number of square units needed to cover the surface. And we're going to do perimeter, circumference, and area for just a few of our more famous polygons. Okay, so really basically what I want you to know for perimeter and area would be how to find the perimeter of a triangle, a square, a rectangle, and a circle. And obviously, even though at this level, I could give you a nonagon and you should be able to find the perimeter of that. The area you'll get into that idea probably in a further chapter, like chapter, I want to say 11, but further on down the road, you'll figure out how to find perimeters for perimeters and area for pentagons and hexagons and regular shapes. All right, so to find the perimeter of this triangle, notice they've given you A, side B, side C, and then a height. That's what H stands for. So perimeter would just be A plus B plus C. The area for a triangle is half of the entire base. Let me highlight that. Half of the entire base times the height. So I probably should have put B here, but it doesn't matter because we can follow a formula. Half of the base times the height. Or just do the base times the height and take a half. With multiplication property, we can do that. A square has all congruent sides and all congruent angles, so it would be side plus side plus side plus side, or 4 S's. But again, you could just add up each one. The area would be side times side, or side squared. For a rectangle where it has 2 different lengths and a width, the perimeter, again, if this is W, this side is W. If this is L, this side is L. So your perimeter would be L plus W, or 2 L's plus 2W. Your area would be length times width. Some books have base times height. It doesn't matter. Just you know how to do this. You should have been doing this from a long time ago. Circle. Circle has 2 parts, and it also has 2 formulas for circumference. It doesn't matter which one you use. You just want to always use and get the right one. In a circle, you have a diameter, and then you have a radius. The diameter is 2 radiuses put together. So I could have put an R here and an R here. Okay, remember, radius is like goes from the center to the out part of a circle. So if I want to find the circumference, the distance around the circle, I do 2 pi r. Well, 2 r's make up 1 d, so I could have done pi times d. The area for a circle, pi r squared. Pi r squared. And we are going to practice that and then end this video. So we are going to find the perimeter or circumference and area for some shapes right now. So real quick, get out your calculator, follow along with me. So this looks to be like a rectangle. I like to, label my sides as I go around. That's 3.2, that's 2.1. And I don't care if you use the formula like 2 times this. I mean, if you just want to write 3.2 plus 2.1 plus 3.2 plus 2.1. And to be honest with you, for perimeter, anyway, I don't think you need to show that much work for this one. And I get 10.6, and you label perimeter by its unit, so centimeters. For area, I would like you to show me what you multiplied together, but you get 3.2 times 2.1, and I get 6.72 centimeters squared, because remember, area is the amount of square units covering the surface. So easy. All right, a circle. Oh, they gave me the diameter. Okay, no problem, easy. No matter what with a circle, I always find the radius because the area formula needs a radius. So I'm just going to cut 6.2 in half, and I get, obviously, 3.1. So I know that's my R. So my perimeter, or my circumference, I should write, would be pi times the diameter. Now, you all should know what pi is. Pi is my favorite thing in the world. It's the lovely day in March 14th. because pi is 3.14. It's actually an irrational number. It keeps on going and going, but that's the day we celebrate it. And we'll celebrate it again this year. And we'll make sure Mr. Calloway has some fun during that day. 3.14 times 6.2, and I get 19.468. And again, depending how the book asks you to round, make sure you round to the nearest correct unit, and that would be inches. For area, you have to do pi r squared, which would be 3.14 times the radius that I found squared. So 3.14 times 3.1 squared gives me 30.17. So I'm going to go 30.18. The 5 is afterwards. And that would be inches squared. Okay, so easy. Let's do 2 more here. All right, we're going to find the perimeter of a triangle here and here. And there's a reason why I gave you 2 of them. So again, walking around the perimeter, don't worry about this guy. He's the height. He only is needed for the area. So perimeter would be 10.2 plus 9.5 plus another 9.5 plus 9.5 gives me 29.2. And that would be meters. Area, remember, is 1/2 the entire base times the height. So, and it doesn't matter how you put that in. I usually just do 0.5 times 10.2 times 8, and I get 40.8 meters squared. Now this one, perimeter, they don't have a missing side. Ha, but this is a right triangle. And you should know how to find the third side of a right triangle. You have to use Pythagorean theorem. A squared plus b squared equals c squared. So I would just do 7 squared plus the other 7 squared equals my hypotenuse, which is missing. So 49 plus 49 is 98, and take a square root. And you can round it to 9.9. So this side is 9.9. So my perimeter would be 7 plus 7 plus 9.9, or 23.9 centimeters. Okay, and then area of a right triangle, your base and your height are always perpendicular. Notice I've always had a right triangle, a right angle there. So your base and your height would be the 2 that make it the right angle. So I would do 1/2 times 7 times 7. So 0.5 times 49 is 24.5 centimeters squared. All right, and then one more interesting one. Actually do one very similar to this in calculus. So if it feels good, you're doing a calculus problem right now. Find the perimeter and area of parallelogram ABCD with vertices at A 1, negative 1, negative 1, B is at 2, 2, C is at 5, negative 1, and D is at 2, negative 4. So I'm going to plot these points and label negative 1, negative 1, A. B is at 2, 2. C is at 5, negative 1. And D is at 2, negative 4. And I'm going to draw my little figure here. Now, you are asked to find the perimeter and the area. Well, to find the perimeter and the area, we would have to use a distance formula. Okay, so the perimeter needs to know each of these distances. So let's find out what, we'll start with AB, distance side is. And that would be, let's see. If you remember your distance formula, the square root of, you would subtract your x's and square them. So -1 minus 2 squared plus -1 minus 2, which is your y's squared. So that's -3 squared, which is 9, plus another 9, which is the square root of 18, which is roughly what? Let's find out. 4.24. Okay. Now let's find AD. So AD, so again, subtract your x's, square them. Subtract your y's, square them. So the square root of -1 minus 2. Whoops, that comma wasn't supposed to be there. -1 minus 2 squared. Plus, now subtract your y's. -1 minus a -4 squared. So let's see, -1 minus the square root of 9 plus 3 squared is 9. Oh, another square root of 18. Interesting. What kind of shape do you think I'm getting? It doesn't look good on my picture here because I do this on purpose. What haven't I done yet? Let's do BC. So B to C, subtract your x's. I would get 3 squared. I'm skipping steps because I think you know where I'm going with this. Subtract your y's. 2 minus a -1 is 2 minus a -1 is 3 squared again. Oh, I'm going to get that square root of 18. So what shape do I have then? Well, they're all equal. They would all be, this would be a square. Actually, it would be a rhombus by definition. We would only know that all sides are equal. We know it's a rhombus. To prove that it's a square, we would actually have to check to see that these two sides are have perpendicular slopes, which is what we do in calculus, and we prove it. But we're going to go with the fact that it is a square, and I mean, you can test that CD is also square root of 18. So you are just going to say the perimeter is 4 of the 4.24s, or 4 square roots of 18, and get your answer to be square root of 18, let's see, 16.97. And you would just say units. And then the area would be side squared, or square root of 18, which was its side, squared. Hey, what happens when you square root a square? It comes out. Okay, and that's it. That's today's lesson. Enjoy.